Now let's look at what happens when the resistors are connected in parallel. A parallel connection of two resistors is as follows. Let's say that this is R1, this is R2, and now they are connected in parallel like this. We can now connect this to an ideal EMF, delta V. And so the current here flows again from a higher potential to a lower potential. So it's pointing like this. And let's see what happens when it gets to this point. Remember what the analogy that we discussed. We should think of the current as water, which is flowing in a pipe. So when the current, that is the water, comes to this junction, it splits into two. So this current I now splits into two currents, I1 and I2. And then recombines again. Just as it was with the series connection, we want to find out what is that value of the resistance that will substitute this combination. Okay, this is what we're looking for. Now, we can realize one important thing here. The voltage drop between these resistors is the same as the voltage drop between this resistor. Why? Because these wires, they have no resistance to them. So this voltage drop between these 2 points is the same as the voltage drop across these 2 points, which is also the same as the voltage across these 2 points. So we can now say that delta V is equal to delta V1 and is equal to delta V2. That's one thing. Now let's use the fact that this current splits at this point into two currents. So we can now say that the current I is equal to I1 plus I2. From the Ohm's law, if we just look at this resistance, we know that I1 is equal to delta V1 over R1. So I can now say that this is equal to delta V1 over R plus, the same thing is true for the second current, delta V2 over R2. Then, now we want to change this combination of resistors by one single resistor. Okay, so now I'm changing this by one single resistor, which I'm going to call R equivalent, such that it drives the same amount of current. Again, using the Ohm's law, we can see that if the current is the same, so I is equal to delta V over R equivalent. And now all we need to do is we need to combine these two results. So we can see that delta V over R equivalent is equal to delta V1 over R1 plus delta V2 over R2. But now, remember what we said about the delta V's? They are the same. So we can cancel them out. So these delta V's cancel out. And what do we get as a final result? As a final result, we get that 1 over R equivalent is equal to 1 over R1 plus 1 over R2. What happens if you have more than one resistor, more than two resistors, like 3 or 4? Exactly the same approach. So we can now write a general expression. We can say that when the resistors are connected in parallel, the reciprocal of their equivalent is equal to the sum of reciprocals. And this is the formula to calculate equivalent resistance when connected in parallel.